Okay, so let's go over the second day's problem. So for the second day, what we can see is what we want to do is we want to find the interval for a graph that is negative. So where that would end up being is the negative is going to be here, and the negative is going to be here. So I just have to really find out where that is and that is. So when I look at that, what I would find is that this would start at negative infinity, and it would go all the way to what that point is, and that point is negative 3. Again, we always use the x's, and we never use the y's. Then we would do the same thing over here, where we'd go all the way from 1 to 2. So that would be the second interval from 1 to 2. And for the negative stuff, you'd need both. Like, you can't just have one or the other. You'd need both the intervals. So negative would be down here, and positive, if you had to do that, would be up here. Okay, so for the second problem, what they want us to do is they want us to distribute. So we're going to take this and distribute. Oh, let me not grab the eraser. But we're going to distribute this to here and this to here, which will give me 9 plus 6i. Then what we're going to do is we're going to distribute this to here and this to here, which will give me negative 6i minus 4i squared. Well, we know that the positive 6i and the negative 6i would cancel. And so what you're going to be left with is 9 minus 4i squared. But what you should know is that an I squared really means that you have a negative 1. Like I is the square root of negative 1. So I squared would just be negative 1. And so when we see that, we would get 9 minus a negative 4, which would be 9 plus 4, which would be 13. And so that would be my final answer. Try the next one. Okay, so the question is this a factor? And so if we're going to know is this a factor, the other way they could say that is like, is 2 a root? So you want to know how to say this both ways. They could ask, is this a factor, or is 2 a root? So how would you want to solve either of these is you'd want to use some synthetic division. So for the synthetic division, I'd have 1, negative 1, negative 1, and negative 2. And then I'd have my box over there. And again, you want to do the opposite of this, which would be a positive 2. And so when we would end up doing that, the 1 is just going to drop down, and I'd get 1. Then you take this number and times it by this. So that would end up giving me 2. Negative 1 plus 2 would be 1. Times that by 2. Negative 1 plus 2 would be 1. Times that by 2. Negative 2 plus 2 would be 0. Yay! This is a factor, and it's also a root because we have no remainder. So anytime you have no remainder, this is yes. Big exclamation mark. This is a factor and a root, which makes this really nice because you could take x squared plus 1x plus 1, and you could actually use the quadratic formula and get 2 more answers from that. So anytime we have this, this is a good case scenario because now we can find more answers. Let's do the next one. I know this is a little bit small to see, but if you're looking up there, what you can find is we're going to use elimination for this thing again. Now, if you look at the bottom, it's really close to working out. The only thing that doesn't work out is that we have a negative and a negative. So I'm going to switch all the signs like we kind of did yesterday. So I'm going to get negative 7x minus 2y equals negative 13. And this would be negative x plus 2y equals 11. Now I'm going to add that together. So that's going to cross out. That's going to give me negative 8x. And this would give me negative 2. Oh, whoops. That would also be negative since I had to switch all the signs. So that would be negative 24. Then I would divide both sides by negative 8. And that's going to give me x is equal to 3. Well, now that I have x is equal to 3, what we're going to do to find y is take that 3 and plug it back into one of the equations. I think this equation would be a little bit easier. So I'm going to put 3 minus 2y is equal to 11. Subtract 3 from both sides. then I'm going to get negative 2y is equal to 8. Divide by negative 2, divide by negative 2. I'm going to get y is equal to negative 4. So those would be my two answers, is 3 and negative 4. Let's try the next one. Okay, they want to write a function for this graph. And so how you should look at this graph is you should go, oh, this makes a V shape. Whoops. I know that this is an absolute value. And so because you know it's a V shape, it should make an absolute value. So you should get y is equal to the absolute value. And we have an x over here. And now we have to look and kind of decide what's its transformations, like what's happening, how's it moving, and what's it doing. Well, its slope, if you really wanted to look at its slope, would be up 1 and over 1 each time. So the number that would go in front of here is 1. You can put that, but you don't have to. This number in here is how much it moves in the x direction, which x direction moves this way and that way, or left and right. And so when I'm looking at that, I go, oh, it moves 2 to the left. And since it moves 2 to the left, that would be a positive 2. Because inside the absolute value signs, or inside parentheses, is always like the opposite. And now we're going to look to see if it moves in the y-axis, which is our up and down. So this thing is going to move down 3 points. So since it's going to move down 3, we're going to put a negative 3 out here. And that is how I get my equation. Let's try another one. Okay, so for this problem right here, we can see that we need to graph both these things. I cannot graph this equation in that form it is right now. So we can't graph that in right now. So I'm going to change it so that I can actually graph that line. So we're going to have negative 2x plus 3y is greater than or equal to 0. I'm going to add 2x to each side and get 3y is greater than or equal to 2x plus 0. Divide by 3, divide by 3, divide by 3. That's going to give me y is greater than or equal to 2 over 3x plus 0. Again, to get in a form that you can graph it, you just have to move the x to the other side and then divide the number in front of the y. And so when we get it to here, we want to figure out, well, which line has that? Well, you can see that every single one of these lines actually intersects their 0 and goes up 2 and over 3. So all the lines look pretty much the same. Well, the other reason I converted it to this form is so we could see what this thing is doing. So because this thing is a greater than sign, so you always look at the sign, it's going to shade above the line. So I'm going to look at the line and look for it to shade above. Well, that one shades above. That one doesn't. See how this shades below that line? So B is gone. That can't work. And this one also shades below the line. So that can't work. And this one, again, shades below the line, so that can't work either. So it actually limits you to A right off the bat. But I'm going to look at the other line too, so in case that they actually have two that shade above the line, because that's weird that they gave you 3 choices where all these are below and that's one above. And this one right here, when you're looking, it would say that Y is 2. Well, where's Y2 at? Oh, it's right there. And we can see, oh, it's a cross, so dot, 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 dot. So anytime that it doesn't have a line underneath, that's a dotted line. Anytime it does have a line underneath, that's a solid line. Let's do the next one. Okay, so let's say we got this problem here. This is a lot like one of the problems yesterday, because again, you have an x squared and you have no other variables. So all we would do is solve that. So I'm going to add 10 to both sides. We're going to get 4x squared minus equals negative 25. Then what I'm going to do is I'm going to divide both sides by 4. That's going to give me x squared is equal to, now this doesn't divide nicely, so let's just leave it. Like if it doesn't divide nicely, you just leave it and we'll deal with it later. So that'd be negative 25 over 4. Now we're going to take the square root of both sides. When I take the square root of both sides, I do need that to be a plus or minus. And so we're going to have x equals plus or minus. The square root, the nice part about fractions is if you have a fraction, you can take the square root of the top and the square root of the bottom and get rid of the square root. And because we can take the square root of the top and the bottom, we can write it that way. So the square root of 25 is 5, but because it's a negative, I'm going to put a little I attached to it. And the square root of 4 is 2. So that's going to be my final answer. And again, if you think from before, when you look at this, you go, oh, look, this thing has a squared. So because this thing has a squared, I should have 2 answers, plus or minus. If you don't put 2 answers, you know right off the bat it's wrong because you didn't deal with that plus or minus. Let's do the next one. Now this one is going to take a little bit because it's a system of 3 equations. Now the one nice part about this, and they'll do this again for the test, is because of time's sake, we don't want you to solve for all 3 variables because that takes forever. So the variable they want us to solve for is A, which means I would like to cancel out B and C and get A all by itself. So what you don't want to cancel is you don't want to cancel A. And if you remember from before, I told you to normally label these 2 equations, or these 3 equations, and to eliminate 1 and 2, and to eliminate 2 and 3, that's going to give you 2 more equations, and then to use elimination 1 more time on that. So that's what we're going to do. So when I look at, I'm going to take 1 and 2 first. And when I look at 1 and 2, I notice nothing will cancel. And so I'm going to think about what I can multiply to make one of the variables cancel. And I think what we're going to try to make cancel first is we're going to try to get rid of C. Because I would just have to times the top by 2 to make the C's the same. So I'm actually going to do that. I'm just going to times the top by 2. So I'll get rid of these numbers that I had here. Let's do that. So this would give me 6, 2, and 6, and that would give me negative 16. Now we'll add these together. Cancel negative 11a, or whoops, my bad, I canceled the wrong one. Oop. Cancel negative 11a and 1b. And that's going to equal negative 20. So that's one of my equations. Let's do the next one. So now we're going to use 2 and 3. And again, you want to cancel out the c's. So I'm going to have to multiply this bottom to cancel out the c's by negative 6. And I hope I don't make a mistake when I do this because this is going to take a little bit. So I'm going to have negative 5a plus 3b plus 6c equals negative 4. And then we'll have negative 36a, or positive 36a. There's a mistake almost happened because we're timesing by a negative. So that's going to be a positive 24b. And that will be a negative 6c. And that's going to give us a positive 120. And now what we do is we're going to add straight down. So that's going to give me 31a plus 27b. The c's are going to cancel. And that will give me 116. So these are not the prettiest 2 equations, but the nice part is we do have a single b. So then when we stack these 2 and eliminate, a will not be too bad to get. So we're going to take this one and eliminate. So let me put that one beneath it. So that'd be 31a plus 27b equals 116. Now to make them cancel, because that is 1b, I'm going to times this equation by negative 27. So let's rewrite those things where we've times by negative 27. So that's going to be 11 times 27, positive 297. Come on. Work for me, pen. That'll be negative 27b and that would be 540. Getting a little nervous that this might not work out when I add them, but we will see. They are pretty big numbers, so I think it's okay that they're getting bigger. That's going to cancel. 297 plus 31 is 328. And 540 plus 116 is 656. And I think that actually did work out nicely. Divide that by 328, and we get a is 2. Huzzah! Came out to be a whole number. So, when you're looking through that thing, this process does take a while, but you can do it. So you eliminate the first two, you eliminate the second two, you're going to get this new equation, and you eliminate the two from the new equations, and then you'll get a single number. On the test, because this takes so long for the final, what I would do is I would do this question like last. I would skip it. And then if I had time at the end, I'd kind of go through it. If I was running out of time at the end, I'll take a pot shot. Because the biggest problem is you don't want to spend 10 minutes on this problem, and then there's other problems that you actually know how to do, or maybe you can get 4 or 5 problems done in the time it takes this one. So worst case scenario, I would skip this one and save this one for last because of how long it just takes. Let's do another one. Hooray, some more synthetic division. So let's just do some synthetic division. These can have remainders because I don't know if they're factors or not, so if you get a remainder for these things, don't panic. The one mistake that a lot of people make is this is not, like the 8 here, you have to switch it, like you have to get a root to put for synthetic division. So we're going to get 1, 14, 1, 14, and 38. I always do a dotted line so I can remember that that's going to be my remainder. The 1 is going to carry down. 8 times 1 is negative 8. 14 plus negative 8 is going to give me 6. And we'll multiply again. That's going to give me negative 48. 38 plus negative 48 is negative 10. Now we have to write what this would be. It's always, when it divides, it's always 1 degree lower because you are dividing by that 1. So it kind of like reduces it. If you think about like what r squared divided by r would be, that'd be 1r. So it's like reducing that root by 1. So this is going to be r. This is going to be 1 lower than r, which would be plus 6. And this is going to be the remainder, like we said before. If I ask you, is this thing a factor? You'd say no. And if I ask you, is this the root? You'd say no, because it has a remainder. So it's not a factor or a root. Let's try another one. So this one is very similar to the last one, if you need to know how to do the last one. The only difference is this time I put a 4 in front of this, but you'll see that it won't make too much difference. So again, what you want to do is go, oh, that is my negative. So that's the factor, that's not the root. The root is always what makes this 0, so that would be 2. We're then going to put down 4, 1, and 1. I always make a line so that I remember this is the remainder. The 4 is going to drop down. Then I'm going to do 2 times 4, which will give me 8. I'm going to add that down, which will give me 9. And 2 times 9, which will give me 18. I'm going to add that down, and that's going to give me 19. Again, because you're dividing these things, the degree always goes down by 1. So I'm going to get 4x plus 9 with a remainder of 19. And that would be my final answer. Let's try another one. So we have another elimination problem. With this elimination problem, here's what I would do is the bottom you can fix by just changing the signs. So I'm going to just flip the signs through, and I'm just going to add. So we're going to add straight down. That's going to give me x. That's going to give me nothing. And that's going to give me 7. So x is 7. If I know x is 7, how can I find y? I just plug that in. So it'd be 14 minus y equals 17. minus 14 from both sides. It's a negative y equals 3. Divide by negative y equals negative 3. And those would be my two answers. Here's what I'd recommend for these problems too. Realize this is a point. Like, they could ask you to solve this by graphing. And on the final, you don't have to solve it by graphing. They could ask you to solve this by substitution. And on the final, you don't have to solve it by substitution. I would solve it using elimination or solving it whatever method works best. And then if they want you to show you where that point is, on a graph, you could just go over 7 and down 3. So just find that point right there. So any of the elimination ones, you can always bring it back to like the idea of what you're finding. You're finding a point where these two lines are crossing. Let's do the very last problem. So for this last problem, what they wanted to do is find the possible roots of this. And so if you remember from before, the possible roots is whatever divides that final number, which what divides that final number would be plus or minus 5 and plus or minus 1. That's true anytime we don't have a number in front of our x, like our first one, our x to the 4th in this case, but it could be x to anything. So your first number, that's true every single time. So for the test and for all the stuff leading up to the test, most of the examples we got didn't have a number in front of there. So because this one has a number in front of there, there's also a couple more roots that you could possibly get. They're anything that, like, it's anything that, like with 3 dividing any of these roots. So you take these roots and you divide them by the number in front. That also will work. So like 1/3 would work. Or 5/3 would work. And again, it would be plus or minus. So if there's no number in front, you don't have to worry about that because 5 divided by 1 is just 5 again, and 1 divided by 1 is just 1 again. But if there is a number in front, we do need to divide the front number by both of these. So you find all the things that will divide it, and then you put all the things that will divide it a separate time over 3. The general form for this is it's a factor if it divides the last number or if it divides the last number and is divided by the first number. So there's a lot of different factors and roots. Generally, I don't check them all. Like generally, I check these positive numbers right here, and if it wouldn't work out, I'd go to the graphing calculator pretty quickly just to see where it did cross. Because remember, for these roots, if you had to, you could graph this 4th degree polynomial, which looks probably something like this, and there's probably some real roots where it's crossing the axis. So that's a basic idea for how to do every problem. I know this video went kind of long, but again, for any of these videos, what you just need to do is just watch the problems that you got wrong. And we really want it, our goal is to try to keep correcting this to make it better.